Now, some of you may have started working on your quizzes or homework assignments in Pearson. That's a great idea. And I did want to mention that there is a video found on the class Moodle page that tells you how to graph using Pearson. Sometimes it's a little bit difficult to figure out how to use Pearson for graphing. So take a look for that on the class Moodle page. Now, in the last lecture, we were graphing using ordered pairs. And I said that you could use any value for X or Y. And then find the missing coordinate. Today, we want to be a little bit more specific. We want to look at graphing using the intercepts. Why is it doing that? This is important. This is a place where lots of people make mistakes on Pearson. Lots of people make mistakes on their final paper exam because they're not paying attention to what they're being asked. Now, let's go back and look at some of the graphs that we made. This graph has a point on the x-axis. This is known as the x-intercept. It has the ordered pair -4, 0. Let's look at another graph. Here we have our x-intercept. This is the ordered pair 0, 0. Another x-intercept. The ordered pair here is 6, 0. What I want you to notice for each of these x-intercepts is that y is always 0. So the x-intercept is the point on the graph that touches or crosses the x-axis. Y is always equal to 0. So this is the point where x is some number and y is 0. X-intercept, y equals 0. X-intercept, y equals 0. Always. It doesn't matter what you're graphing. We could be doing a graph that has curves going up and down and sideways. But if we talk about the x-intercept, y equals 0. Let's take a look at the graphs again. Here's a point on the y-axis. This is known as the y-intercept. This is the ordered pair 0, 2. Are you noticing something? This is also our y-intercept at the origin 0, 0. We have a y-intercept here. At that ordered pair, at that ordered pair, 0, -3. Do you notice that for each of these, x is equal to 0? X is equal to 0. X is equal to 0. So the y-intercept is the point on the graph that touches or crosses the y-axis. This is the place where x equals 0. So in my ordered pair, x is 0 and y is any other real number. We want to graph using the intercepts. That means we want to let x equal 0, find the missing coordinate, and then let y equal 0 and find the missing coordinate. So the first thing I would do in my table of values is fill in x equals 0 and fill in y equals 0. And then we can use substitution to find the missing coordinate. When x is 0, we have 2y equals 6. We know that y is 3. If x is equal to 0, we're finding our y-intercept. Next, we want to let y equal 0. So we have negative x equals 6, or x equals negative 6. When y is 0, we're finding our x-intercept. Now, we could just connect these dots, but remember what I said in the last lecture. It's a good idea to find 3 ordered pairs, just in case we made a mistake. The third one confirms that we are on the right track, and you can choose any value you want for y or x. I'm going to let x equal, let's say 4. 4 seems like a good idea. Now remember, this is just checking that our x-intercept and y-intercept are correct. We could just join those dots now, but we want to be sure. So we have negative x plus 2y equals 6, and x is 4. So I'm going to add 4 to both sides. So we have a point at 4, 5. Yeah, that seems to confirm that my x and y intercept were correct. We can draw a straight line and it goes through all 3 points. The important thing here is that we used the intercepts to graph. So here's another equation. I want you to graph using the intercepts. That means we're going to let x equal 0 and y equal 0. Pause your video and find the graph for this equation. What point do I want to use here? Maybe x equals -1. You can use anything. So I'm going to add 4 to both sides. -8/3. Yeah, not a really nice number. What is that? When x is -1, that would be -2 2/3. That doesn't look very good, does it? -1, 2 and a bit. Yeah, that looks like it will fall on my line that I want to graph. Oh, I've been forgetting to label my X and my Y axis. It is a good habit to remember. Your calculus professor might find that very important. All right, one more equation. Let's graph this using the intercepts. Pause your video, give it a try. Now this graph is a bit of a problem. When I let X equal 0, I get 0, 0. When we let Y equal 0, we get 0, 0. We definitely need to find one more ordered pair. You can choose any value for X or Y. Any value, it doesn't matter. So if we let X equal 1, then we would have Y equals -2 times 1. And we see that Y equals -2. You may want to check one more value to be sure that these are correct. But again, 2 points always gives you the equation of your line. I think I want to stop there. Oh no, let's look at these special cases. We have 2 equations here. Y equals 3 and X equals -2. In the first one, there's no X value. In the second one, there's no Y value. Now let's think about our standard form for the equation of a line. If Y equals 3, what does that tell me? Well, it tells me that A must equal 0. When A equals 0, I would have BY equals C. And in this case, Y equals 3. I know that B must equal 1 and C equals 3. This is still the equation of a line. A is just 0. That's okay. This is also important because it tells me that Y equals 3. Y equals 3. There's nothing else I can put in there. Y is always 3. X can be any real number. That means that we can let X equal 0. We can let X equal 1. We can let X equal 2. We could let X equal 5,689, and Y will still be 3. In fact, instead of 2 here, let's make it a -2. So then we can graph 0, 3, 1, 3, -2, 3. I don't know, 5,689 3. That's way down here somewhere. But what do you notice? When we connect our ordered pairs, we have a horizontal line. Let's look at the other one here. Oh, I seem to have moved my graph accidentally. Let me see if I can get it back. There we go. Good enough. In this one, x equals -2. So if we go back to our standard form for the equation of a line, x equals -2. That means that b must equal 0. And we're left with a equals 1 and c equals -2. It's still the equation of a line. But what do we know for sure? We know that x is always -2. And y can be any real number. Any real number. It doesn't matter. So we can let y equal 0. We can let y equal -4. We can let y equal 3. -2, 0. -2, -4. -2, +3. When we connect our ordered pairs, we see that we have the graph of a vertical line. We're going to stop there. I'm going to give you some time to think about that. Y equals 3 is a horizontal line. And x equals -2 is a vertical line. We'll talk more about that in the next lecture.